Okay, welcome everyone. This is the week 2 webinar of the online statistics class. And thanks for coming. So let me tell you the plan today. As always happy to answer any questions throughout the entire webinar. Just pop in the chat box, or if you want to say them, you can. Either way, if you put in the chat box, it's private. If not, then they hear you, but most people won't recognize your voice anyway, but you choose. And always happy to answer questions. And then we're going to move on to chapter 3. I want to give you a bit of a heads up about chapter 3. Chapter 3 is probability. And my favorite analogy for chapter 3 is that it's a whole lot like kickboxing. Okay. Kickboxing, if you sit there on TV, if you watch on TV and you watch kickboxing, it's like no big deal. You're just watching. But if you actually have to do it, it's a whole different thing. And trust me, I used to teach karate, so that was my thing. You feel like you're getting beaten up if you're actually in the ring doing it. So it is tough, and you do want to reach out and get help as you're getting stuck on questions and trying to figure things out. But make sure that you don't just give up. You know, there's lots of help for you. The tutors will help you out. I'll help you during office hours. I'll answer questions on the Q&A, whatever it takes. So the other cool thing is, at least I am, and some of you are also, in like the perfect place to talk about probability. Okay, what's great about Tahoe and probability? Any thoughts? There's other perfect places too. That's a hint. Weather, yeah, but that's actually too hard to even talk about probability with the weather because they're always wrong. All right, let me show you. That guy and these guys. Gambling. And I'll tell you, gambling has a lot of probability in it. And I know from both sides, actually. So, you know, you don't have to gamble. And I will tell you that your probability of losing money is pretty high if you gamble. So just a warning, but I'm going to kind of show you, you know, dice examples and card examples, and even coin flick examples, those kind of things, and we'll do probability. All right, but before I do that, let me finish what we're talking about today, and then I'm going to introduce an important person here. And we'll talk about probability. I'll even see, well, what do you think? Am I going to be a multimillionaire? We'll find out the probability of me winning, and we'll find out. This sounds really easy. We'll talk about and. And sounds easy. It isn't. We'll talk about or, also sounds really easy, but that's a word in probability, and we have to deal with it. We'll talk about given. So it's a lot of different vocabulary words for probability. We'll talk about what it means for two things to be mutually exclusive. That's actually not too bad. Then we'll talk about what it means for two events to be independent. And that one takes a little bit of calculation. We'll have that. And then finally, we'll get into a discussion of project 1. So hopefully you all have partners, and this is the week that you get to start working on it. And you have some weeks to do it, but it's an important project and it does take time. So I want to introduce a very important person here who's coming in to talk to you. And that is Manuel Sanchez. He is the director of the HSI. It's a help STEM students and all kinds of stuff, but I'll let you explain all the stuff you're doing and what you're talking about. And Manuel, you want to unmute yourself?
Absolutely. Thank you, Larry. Do you think I have, can you hand over the reins so I can share my screen real quick?
Yeah, I have to stop share for you to share. Now you can share.
Okay.
Yeah, and this is recorded.
Awesome. Thank you. So let me go ahead and pull this up. There we go. All right. Can everybody see that okay? Okay, awesome. Thank you. Hi, everybody. My name is Manuel Sanchez, and I am the director of the Hispanic Serving Institutions Initiatives here at Lake Tahoe Community College. And today I wanted to take a few moments of your time to talk about Lake Tahoe Community College, its designation as a Hispanic Serving Institution, what that means for our school, and what that means for you as our students. And so Dr. Green has been, super accommodating and allowing me to come speak with you. Um, First of all, uh, we have an Office of Hispanic Serving Institutions here at Lake Tahoe Community College. And before I get into what it is, there are 3 of us here in this office currently, and we're adding more team members as we go along. I am the director of the Hispanic Serving Institutions Initiatives. We have a gentleman named Steve Huerta, who's our HSI retention specialist. He supports students in completing their college pursuits. And then we also have an HSI peer ambassador, a student named Vanessa Velasquez, and she'll be working with us when we do events and outreach here on campus. So currently there are 3 of us in the HSI office. We're located upstairs on the 2nd floor above the common area, and I'll talk about that here in just a second. So what I'd like to do today is I'd like to talk to you about what is an HSI and what does that do for Lake Tahoe Community College. So first and foremost, Lake Tahoe Community College is designated a Hispanic serving institution under the Department of Education. And what that means is that we have at least 25% of our population, full-time student population, is Hispanic or Latino. And what the HSI designation does for us is it allows us to access federal funding that supports Hispanic and Latino students, as well as all other underserved students here on campus. And so the mission of Hispanic Serving Institutions is really to kind of bolster and strengthen the programs we have on campus, opportunities for students, services that we provide to students, and specifically targeting Hispanic and Latino students. But also, if you notice on this slide, it says other historically underserved populations. And that's important because what that means is that if it is your first time, or if you're the first person in your family to attend college, you are historically underserved. It doesn't matter what ethnicity you are. If you're a student who has trouble paying for college, that needs financial support, you are historically underserved. If you are a female in college, in a STEM field or a math field or something like that, you are historically underserved. So even though the Hispanic Serving Institution designates Hispanics and Latinos primarily, our programs and our systems of support all students on campus. So you could be eligible to participate in some of the programs that we offer. Under the Hispanic Serving Institution designation, we have 2 grants here at LTCC. The first grant is the HSI STEM grant, and that specifically focuses on STEM students, science, technology, environment, and math students, and it supports recruitment efforts, retention efforts, keeping students on campus, and graduation efforts. So under the HSI STEM grant, we work to support students on their path to completion, whether that's transferring to a 4-year, earning an associate's or another degree, or earning a certificate in a STEM field. The second grant that we have under the HSI designation is the Developing HSI grants. And the Developing HSI grant works to support all the other meta majors, the arts, humanities meta majors, the safety, the public safety meta major, and as well as the others. So with these two grants, we can really support the programs and the services that support all of our students on campus. One of the biggest programs that we offer under the HSI STEM grant is the HSI STEM Academy. And the HSI STEM Academy is a support system that supports our first year STEM students on their pathway to completion. What the STEM Academy does, it allows us to create personalized support systems for our STEM students. It facilitates individual referrals to all the services we have on campus, tutoring and academic support, work-based learning opportunities, which is really, really important for students, and also other LTCC resources that we have on campus that can support you on your path to completion. The enrollment for our STEM Academy is open to all students, but we really want to focus on our first year college students. However, it is open to all students, whether you're a second year or a third year student. You need to be enrolled in at least 6 units and be a declared STEM major. And if you're looking for more information, you can scan that QR code or check out our HSI STEM page online, or even stop by the HSI STEM office upstairs above the Commons. The second kind of system of support that we offer is our work-based learning opportunities. And this is really, really important for some students because it allows you to work and earn money while you're getting experience in an area of your interest or your degree field. So some of the opportunities we offer under work-based learning are shadow days. You can go into, let's say, Barton and shadow a nurse for a day to see if nursing might be a career field that you're interested in. We offer part-time internships during school. We offer full-time internships during school and also during the summer in STEM-related fields. So if you're interested in work-based learning opportunities, the STEM Academy might be for you. Some of the partners that we have for work-based learning opportunities are the Forest Service, the Lake Tahoe Basin Management Unit, and Barton Hospital, as well as a bunch of others. So if that's something that interests you, you might want to join the STEM Academy. As I mentioned earlier, our office is located upstairs above the common area. We're located in A256, across from all the little cubicles on the second floor there. And in the HSI office, you can schedule one-on-one meetings with myself or our retention specialist, Steve Huerta. We have a student-friendly space where you can come in and it's a quiet place to study. We've got whiteboards that you can use if you want to practice some of your equations or things like that. We do have a microwave and some snacks in here too, if you ever get hungry and you just need a little pick-me-up. So that is a quick rundown on what are HSIs and how Lake Tahoe Community College, the Office of HSI Initiatives, can support you on your pathway to completion. Once again, my name is Manuel Sanchez and I'm the director. We have Steve Huerta, who's our retention specialist, and Vanessa Velasquez, who's our peer ambassador. If you have any questions or would like to talk about anything STEM related or work-based learning related, come by, shoot us an email, or just find us as we walk around campus. Say hi and ask us what you need. So Larry, I think that's about it. Students, are there any questions that you guys have for me while you have me here regarding HSIs or some of the services we offer? Okay, looks like they don't have any. Let me see. I'm going to switch over. So if you're interested in the LTCC STEM Academy, you can scan the QR code here, or you can also swing by the HSI office on the second floor. If we don't have any other questions or any questions at all, Larry, I think that's about it.
All right, thanks a lot. And if you have any questions later, I can always, if you even forget where to get them, I can refer you to them and walk you over from my office, which is about a 5-second walk.
That'll be
Yeah.
fantastic.
Yeah, so just let
Appreciate
you
it.
know they're there for us. So make sure take advantage of whatever help you can get. Okay,
Absolutely.
thanks a lot.
We will be sponsoring some tutoring sessions for midterms and finals, so keep your eyes and ears open for information regarding that. And also, dinner is always served at those events. So, Larry, thank you so much. Students, have a great day, and we'll talk to you guys soon and see you around campus.
Thanks. Now we'll
All
get
right,
back to
thank you.
probability. So let me, why don't you unshare your desktop so that I can share mine?
Got it. All right, guys. Thank you and have a great day.
Okay, it's a really good program at HSI. So now we get into probability. So let me are there any questions about anything about the class? Hopefully you all have partners now. You've had some time now, and hopefully you got partners for the projects. And any questions about anything before I move to probability? Okay, if there's not, that's fine. And if you come up with some, put them in the chat box or ask them, and I'll answer them as we go. That's what these are all about, these webinars. I'm not just, making you watch a video. This is supposed to be interactive. Okay, so the idea here is I have this wonderful deck of cards. It's a little depressing if you live in Tahoe, because it's Lakeside Inn, which is fell apart, doesn't exist anymore. But they gave me these cards. And if I just grab a card and randomly pick it, we can look at what is the probability that this card is heads, or what is the probability that this card is spades. So we can do all kinds of different things to decide on probability. Okay, so let me erase these and let's start again because I have some different stuff. So how do you find out the probability? Not how cards is head. Sorry, I'm going to flip a coin. And what's the probability that my coin flip? Now, what's the probability? I'm not showing you. What's the probability that this flip is a heads? That should be easy. Yeah, 50%. I want to let you know if we ask for probability, you always want to write it as a decimal. If we ask for percent, that's going to be the whole number. So probability can never be bigger than 1. Okay? And it can't be negative either. So the idea, kind of the way the definition works, is you look at a coin, and hopefully this is obvious. How many sides are there of a coin? There's 2 sides. How many of those sides are heads? There's 1. So by the definition of probability does the following. Equation. It's a fraction. So that's one thing that's really important. Probability is a fraction. So I'm going to make a fraction. And the numerator of that fraction is the number of ways that makes you win. Although win isn't the best word, but makes what you're asking for happen. So it's how many ways of getting ahead out of this flip. Well, there's only one way of getting ahead. And the denominator is how many different things can happen. In this case, there's 2, heads and tails. So the probability of heads is 1/2. Any questions on the very simple example of the probability of heads? Okay, so now we're going to do something similar. Okay, and by the way, I don't expect all of you to know everything about cards. But if I grab a card and randomly pick the card, what's the probability that this card is a spade? So what we're going to do is we are going to make a fraction. It's always what you want to do is you want to write down a fraction. And we say, how many of the cards are spades. So here's a hint. Here's 5 of spades. Here's 10 of spades. There's a whole lot more of them. How many of these cards are spades? Yeah, there's 13. So if you don't remember cards, I'm going to tell you now. There's the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. And I know I went fast, but if you counted how many things I said, it was 13. There are 13 spades in this card deck. How many of those how many cards are there? How many different things can I pick out of this deck? Yeah, there's 52 different cards in the deck. So the probability of getting a spade is 13 over 52. So let me stop. Are there any questions on that probability where it's just basic counting? Okay, we're going to do more stuff today, but starting out with basic counting. Any questions on finding these probabilities? Not too bad. Okay, just in case, if you don't know cards, there are 52 cards in a deck. There's hearts, clubs, diamonds, and spades. That's 4 suits, we call them. And then for each suit, there are 13 different values, and 13 times 4 happens to be 52. Okay. So that's it. And I will let you know. Any guess on how I made a lot of money using this? This probability stuff with cards? Yeah, at the casino, I was a card counter. It was great until they told me that they'd kill me, and then I stopped playing because I'm not stupid. So yeah, I made a lot of money until the mafia came and said, "You need to get out of here. You will not live if you ever come back again." So I don't gamble anymore. But I did work for them and help them change the rules so people like me can't win. Just let you know. So now if you go and lose, it's my fault because I changed the rule, made it harder. Okay, a long, long, long time ago when the mafia was in charge of the casinos. That was in Vegas. Okay, and it was all about probability. Yeah, so I was counting the cards, computing the probability, based on the probability, deciding the best strategies and making that strategy happen. And that is how I was able to use probability to make money. Okay. Yeah, so I was a serious card counter. Okay. I'm not the one they made a movie about. I think I was a student, actually. They didn't make a movie about me, but actually my system was better than the movie system in terms of probability wise. Okay, so definition of probability. So this is kind of what I just said is the probability of A. Okay, we often use capital letters if you're just using a variable, and A is the first letter of the alphabet, so we often use A. And that is equal to the number in A divided by the number in the entire set. Any questions about the definition? Okay, so now let's get more complicated. Okay, and you're going to see why card counting is not as easy as it sounds. Let's suppose now I pick 2 cards. Got it? I just picked 2 cards. What's the probability that the first card is a king? I'm going to call that P parenthesis K1. P, by the way, when you see a capital P, that's the probability of. Got it? Okay, I'm using K for king. That's not math. That's just a letter. And 1 because it's the first card. So what we need to do is we need to make a fraction. And let's do it. And we say, well, let's see how many ways are there for this first card to be a king. Okay. And I see in the chat box, we got it, but let's do it slowly though. There's king of spades, king of hearts, king of diamonds, king of clubs. There are 4 kings in the deck. So the numerator is 4. The denominator is 52. Any questions on that? I do want to give you a heads up about like the chapter assignments and the exams. And that is that sometimes that's fine to leave it as 4/52. It all depends on the instructions. Sometimes they want you to reduce the fraction, but it'll say reduce the fraction if they want that. And 4/52 is 1/13. You can do 1 divided by 13. And sometimes they want you to write it as decimal. And whatever the instructions say on the homework, then that's what you should do. What do I do to plug in for P? Oh, P? P is just the letter that stands for what is the probability. It's not a number. It's the question. Does that make sense? And then K, 1 meant king for the first one. And then in the instructions, it said I picked a card out of the 52 card deck. Does that make sense? Yeah, so that the P is just the letter you use to say you're talking about probability. Okay, now, what is the probability that both of these cards are kings? That one's a lot harder. Good luck just counting all the different ways of getting 2 kings like this. Okay, any questions on why it's a lot harder? Okay, so what we need to do now is we're going to use something called the multiplication principle. Okay, and the multiplication principle says the probability of A and B is equal to the probability of B, well, let's go A, times the probability of B, and I'm going to put a little vertical line segment, and we read that as given A. So what that means is the probability that A happens times the probability that B happens if you know that A happened. And that's called the multiplication principle. So in this case, we can think of as A being K1, the first is a king, and B is the second is a king. So I need to find the probability of K1 given K2 given K1. So if I know this first card is a king, and what I'm going to do is I'm just going to drop it, and then I pick a second card. What's the probability the second card that I picked is a king, knowing that I just dropped a king down on the ground? Let's do it in fractions. Otherwise, the fractions tell the story a lot more than the decimals. We want to find out the probability the second card is a king if you know the first card is a king. So what I'm going to do is I'm going to make a fraction. We're used to that. Okay, so if I know this card down here is a king, how many kings are there that this could be? How many choices do I have for this card to be a king? Yeah, 3, because it's not the one I just looked at. It's not the king of spades. That's on the ground. So that's going to be 3 up at the top. And then it's, again, the card can't be this one. So there's only 51 cards left that it could be. And that's 51. So the probability the second card is a king, given the first of the king, is 3/51. Any questions on that? So that means I can put that together, and I could say the probability of the 2 kings is the probability of K1 times the probability of K2 given K1, and that is equal to the fraction, probability of K1 was 4/52. And then times the fraction that we already did. Now we'll use it. And that was 3/51. Okay. And if you want, you could throw that in a calculator. That's what, 12 over 52 times 51. Which is 0.004524888688. Okay, if you needed to write it, if you wanted to multiply that out. Any questions at all on this example? Any questions? And by the way, that's what card counting is all about. Is, you can, before you even get to the casino, you can get all the probabilities of all the different, blackjack and all that kind of stuff. But what happens is when you're playing cards, you get to see some cards. Maybe the last time it was played, or maybe the cards that are around you that are already up. You can move those out, and that changes the probability, and you have to do that in your head, by the way. They don't allow calculators in the casinos. So, but that's what I did. I was able to card count, and I was using this kind of probability questions, and then coming up with best strategies. Okay, so now let's get into poker. I used to teach a class called the Mathematics of Poker. I haven't in a long time, but has a lot of math. And again, I don't expect you to be experts in poker, but I will tell you a little bit just about the question I'm asking. Let's suppose you pick 5 cards. There's 5 cards in my hand that I just picked. And we're going to assume these are randomly picked, no cheating allowed. Got it? Okay, what's the probability of getting a royal flush? A royal flush, by the way, is an ace, king, queen, jack 10, all of the same suit. Any questions on that idea? So the first thing is I need to say, well, that's going to be the number of royal flushes divided by the number of poker hands. Any questions on that idea first? Okay, now, how many royal flushes are there? A royal flush is an ace, king, queen, jack 10, all the same suit. Yeah, there's 4, because they could be ace, king, queen, jack 10 of hearts, of spades, of clubs, or diamonds. Any questions on that so far? Now comes a very difficult question if you have to do this in your head. How many different poker hands are there? And if you think about it, good luck counting every possible poker hand there is that are 5-card poker hands. Okay, you're not going to be able to list them out. Okay, but here's what we can do. We can think about it a little bit about what's going on. How many cards are there to pick from? How many cards are we picking? Okay, we're picking 5 cards. Okay, we're picking 5 cards. Okay, I told you the math is going to be too hard, and I'll show you what we're going to do with it. But at least we can know there's 5 cards we're picking. That you have to know. And we know that we're picking out of a deck of 52. So there's something very special, and it's called combinations. When you're picking a group out of a larger collection, and you don't care about the order at which they're dealt. So in other words, if you have an ace, king, queen, jack, 10 of hearts, and then, or if you had an ace, queen, king, jack, 10 of hearts, that's the same hand. And if you don't know poker, just trust me, that's how it works. So the order at which you pick them doesn't matter. Then we're going to use what's called combinations. Okay, and I've done this before, and now we're going to do it again. When it's hard, what do? When the math is really hard to do? Yeah, you go to the calculator. Okay, and the one thing you have to do, and hopefully you can, is you can trust me that I coded up this calculator correctly, so there's no errors. Okay, and I think maybe over 1 million people have used this calculator, so any errors have been found, I think. Okay, so if I go, what I'm going to go to is number 5, and that's combinations and permutations. And it's very simple. N is the number we're picking from. How many are we picking from? 52. Because it's 52 cards. R is the number of things we're picking. How many things are we picking? How many cards do you pick? 5. It's a poker hand. I told you it's combinations. The first letter of combinations is C. So that's C. If it's permutations, which we're really not going to get into, it's in the book, but I won't test you on it. Then it's P. But it's C and R. And there it is. Like, there's no way you'd be able to count all of them because it's 2,598,960. And there's the probability. Okay. So what do you think? It's pretty likely to get a royal flush in a 5-card hand if it's just the first card you look at? I counted cards for blackjack, not poker. Poker is much harder. Okay, but I have used some of that for poker, but that's too hard to do in your head. That you have to remember. So I do know it's about 2.6 million. That I know. You can't know everything. Oh, I put a 4. Sorry, typo. I apologize for the typo. That should be 5. Wait. No, it's 4. I was right. I'm a sucker sometimes. There's 4 royal flushes: hearts, diamonds, spades, and clubs. It's not 5 cards. It's how many different royal flushes could you get? And there's 4 royal flushes because it's the suit that matters. That make sense? Yeah. Okay, so that's another example of probability. Okay, and by the way, these can get very, very difficult. Even though this looks hard, they can get much harder. The real hard ones you don't have to worry about because they're not anything you'll have to do. But I will let you know that there are some very difficult probabilities out there. And as was mentioned, when I asked you what's important in Tahoe, and most people guess something different, what'd you guys guess? Yeah, snow and weather. I will let you know that truly computing probabilities that involve weather is actually really hard. Like way harder than even master's level. Forget undergraduate. It is really hard, which is why they're almost always wrong, because it's just usually impossible. Okay, but you can do your best. And statistics help some, but you're not going to be right all the time. Just let you know. Okay. Okay, so here's another example. Let's suppose that there's a 20-question 4-answer multiple choice quiz. I'm sure you've all taken multiple choice exams or quizzes, right? And let's suppose that you have no clue. She's going to randomly guess. What's the probability of getting all 20 questions correct? And what we're going to do, as always, is we're going to get a fraction. Okay, does everyone understand the question? Okay, so what we're going to do is we're going to say, well, how many different ways are there of getting them all correct? Right? There's 20 different questions. Each has 4 choices. And there's always only one correct answer for each choice. Yeah, there's only one way, and that's to guess perfect every single time. So that's a 1 in the numerator. Any questions on that? All right. Now it's time for the denominator. And what we're going to do is I'm going to do this a little bit differently. I'm going to look at this one at a time. So look at the first question. How many ways are there of choosing for the first question? How many choices do you have? 4. So that means the denominator, just for the first question, is 4. We got 1/4. All right. Now, the one thing about these is that if you got the first one right, what's the probability of getting the second one right? Remember, you're totally guessing. Still 1/4. If you get the first one wrong, what's the probability of getting the second one wrong? Yeah, 3/4. And what's the probability of getting the second one right if you got the first one wrong? 1/4. Nothing changes. So for the second one, it's also 1/4. So it's 1/4 times 1/4. And how about the third one? What's the probability of getting the third one right? Same. Okay, and the last thing I want to do is write down 1/4 20 times. So instead of writing down 1/4 20 times, mathematically, how can you write that? If we want to multiply 1/4 times 1/4 times 1/4 times 1/4 times 1/4, and pretend I said it 20 times. Yeah, we can write it as a power. So what I can do now is I can take the power of the fraction 1/4 to the 20th power. And that's the probability of getting all 20 correct. 1/4 to the 20th. By the way, and this is really important, it's going to happen a lot in this class. Is the probability 9.09 about? Is that a good approximation of the probability? 9.09. Definitely not. Probability can never be bigger than 1. And this is a very common mistake. So I want to emphasize it. And I'll emphasize it lots of times in this class because it's so common. It means if you ever see a number bigger than 1 for the probability, it means you didn't move your eyeballs to the right enough. What does this E-13 mean? Anyone know? And that's really important. It's going to happen a lot in this class. We're going to have E something, E- something especially. Yeah, it means that it's times 10 to the -13 power. So we're going to move the decimal over 13 places. The first time we just move it next to the 9. After that, you got to stick a 0 every time. So the first is free, and then there's 12 more pushes. So you have 12 zeros before the 909. So the answer is 0 point, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 909. Okay, it is almost no chance of getting them all right. Any questions on that? Any questions? Okay, so just a note, and this is important, is that if you guess, A on your first guess for the question, you're allowed to guess A on the second guess, right? Okay, you're allowed to guess A. Your chat is stuck in the middle of the screen. Yeah, if you're trying to read the chat box, you have to move your arrow to the right, far right, with a little dot, and move it down. Click and move it down. That's on Zoom. How do you do that? That should work. Okay. So I want to talk about with replacement versus without replacement. So if I guessed A on the first, I'm allowed to guess A on the second. So that means it's with replacement because I'm allowed to get the same answer for the second as I got for the first. Whereas our example of picking 2 cards, if I got a king of spades on the first card, I can't get a king of spades on the second card because this is without replacement. Is that clear? Any questions on that? So if it's with replacement, then the probability of A and B is always equal to the probability of A times the probability of B. Okay, which was different than without replacement. Without replacement, remember, we had to do some work. We had 4/52, and we didn't have another 4/52. We had a 3/51. So it's important to pay attention. Is it with replacement or without replacement? All right, so now comes the next question. Y'all see what this is? What is that I'm putting in my video? Okay, well, I hope it's lots of money. Okay, it's a lottery ticket. Okay, so what you may not notice is that I bought two for that ticket. Okay, so I bought two tickets. It gets put on the same little card. What's the probability that I'm going to win the lottery? Okay, and this is Powerball, by the way. I don't know if you noticed, but you have to know the rules. And here's how the rules are. You pick 5 numbers between 1 and 69 and 1 power number between 1 and 26. And you're allowed to pick the same number for each, actually. You're not allowed to pick the same 5 numbers. Those will have to be different. But this last number could be whatever you want. Okay, so we want to find out what's the probability that I won. And I'm very when I say I won, I'm greedy. I mean won the big prize, not won a little. I have won $4 in the past. Okay, because I buy it just so that I can show you that I bought a ticket. Okay, never come back. And what do you think? Do you think it might be a good idea for you to come in, find my office, and run into my door with a gun and steal my lottery ticket? Because it's worth many millions of dollars if it's a winning ticket. Think it's worth it? Think that's a good idea? Okay, if you have a gun, by the way, even if I know martial arts, I can't stop you. Okay, let's find out. Let's see the chance of it being a winning ticket. See if it's even worth stealing my ticket. So what do? Well, there's two things going on. There's the 5 numbers from 1 to 69. So that's going to be the probability of, let's say the 5 are correct. And then because it's with replacement for the last number, we can use this multiplication and say that's times the probability that the power number is correct. Any questions so far? How do I come up with the probability that that those 5 numbers, those first 5 are correct? What do I have to do? The hint is by hand is really hard, but it's actually not that hard if you don't do it by hand. So what do I have to do? Yeah, I'm gonna do that combinations calculator again. Okay, you have to remember that it's between 1 and 69. I'm picking 5 numbers. So now n is 69. I picked 5 numbers, so R is 5. Okay, and it turns out, if you don't know the lottery, you can trust me. Order is not part of the lottery. So if you picked, 7, 3, 8, 1, 2, and they did 1, 2, 8, 7, 3, that's still winning, even though it's a different order. Order doesn't matter. So that means calculate. Okay, and that is 1,123,000. Sorry, 11,238,513. So I can go and say this is equal to, and I can make a fraction. 1 over 11 million something. And then I go times another fraction. How about the other fraction? What's the probability that my power number is correct? How many ways are there of getting the one number you picked right? Yeah, there's only one. And I have a choice between 1 and 26, so there's 26 power numbers. Any questions so far? So now I can go ahead and go 1 divided by that 11 million thing, and then times 1 divided by 26. Okay, and it's 3, again, hopefully it's not just 3.42, but it's about 3.42 times 10 to the negative 9. So that's 8 zeros before the 3.42. And there's my probability that this is a winning ticket. So what do you think? Is it worth, coming in and robbing me? Okay. The answer is probably not a good idea. In fact, if you were to rob me, you're much better off, robbing me of the $20 that are sitting in my wallet in my pocket. Just let you know, because this ticket's not worth or more even close to $20. There are a few people in the United States and it's necessary to win the power lottery. Exactly. And if you follow the lottery, by the way, you will notice that often several months go by before anybody wins. And that's the reason, is that most times nobody wins. Okay, and they take a percent, I don't know what percent, but they take a percent of the amount that people put in and lost, and they add that up to the next one. That's why it keeps going up and up and up and up. When we talk about something called expected value, we'll talk about when it's smart to buy a ticket. And I will let you know today is a very dumb time to buy a ticket. Okay. In fact, should I be honest? This actually is an old ticket that lost. Because I'm not stupid, I'm not wasting money. But when the expected value is positive, which we'll talk about next week, then it's time, then I always buy a ticket. Just let you know. But we're not ready for that yet. Okay, any questions on the lottery example? Do they randomize the numbers? Yeah, I think they actually pick it out of a jar. They have a jar and they spin the jar and they grab 5 numbers and they look at them and those are the numbers. It is completely random. There's no cheating. Okay, so that's how it works. So it is random. Yeah. The only smart thing about picking the right number, and there's all probability also, is that you're smarter picking random numbers at the store, let them pick them for you, than picking your own. Because if you pick your own, you're probably picking favorite numbers, and your higher probability of actually having someone else also win with the same numbers you got, and then you have to share the money. Who wants to share? It's much better just take it all, right? So, statistics wise, it's better to let the computer do it for you. Any questions on the probability idea? Okay, so here's another question. All right, suppose that 20% of all students taking stats at Lake Tahoe Community College are African Americans, and 40% of all stats students at LTCC are non-STEM majors. If 22% of LTCC stats students are non-STEM majors, stats students non-STEM majors are African American, and you pick a randomly selected African American taking stats, find the probability that the student is a non-STEM. All right, so I want to give you a strong recommendation on how to tackle questions like this that are very wordy. Okay, the first step is something you're going to do anyway, so I probably don't have to tell you, but hopefully you know how to do this. Step 1 is read the question. Hopefully you all know how to do that, right? Okay, step 2 is not the step that most of you will probably do. And most of you will probably read the question, go, ah, and then quit. Don't do that. Okay, do you promise? So don't do a common steps 2, which is get so stressed out that you just quit because it's some big long word problem. So instead, here's my strong recommendation for step 2. Okay, my strong recommendation is go back and start over with the question and read it very slowly. And every time you see a number, write that number and what probability it represents in symbols. Any questions on the step 2 suggestion? Because it's way too long a paragraph to just do the whole thing in your head without doing step 2. Everyone agree with that? That if you just just looking at this, you're not going to be able to answer the question without doing all kinds of the little step 2. Okay, so now I'm going to say, suppose 20% of all students taking stats at LTCC are African American. Okay. So what we can do is we can say P of A, I'm going to use A for African American, is equal to 0.2. That's 20%. Any questions how I took that first phrase and turned it into P of A equals 0.2? Okay, so now I'm going to read the next phrase. 40% of all stat students at LTCC are non-STEM majors. Okay, so that's P of N. I'm going to use N for non-STEM. And you could choose a letter, that's up to you. But don't ever choose the same letter for two different things in your list. Use different letters. So P of N is equal to 0.4. Any questions on what I did so far? Okay, and then I read more. If 22%, if 22% of LTCC student non-STEM majors are African American. Okay, so what that says is we're saying amongst those who are non-STEM, 22% are African American. So you are given or told the person's non-STEM. Now the probability of being an African American is 0.22. When you're given something, we're going to use this given symbol. And the probability is probability of being African American, so that's P of A, given non-STEM. Any questions on how I took that little phrase and turned it into a P of A given N equals 0.22? Any questions on how I was able to read that? Any questions? Okay, so then you pick a randomly selected African American taking stats. So now you know the person's African American. We want to find the probability the person is non-STEM. So our question is find the probability of non-STEM, or N, given A. And I'll always write equals question mark. And I think it's really important to write down equals question mark for the question. Okay, this is the hardest part of the entire problem, is to read this long paragraph and write down in symbols what all the numbers were and what the question is. So everyone okay with it? Okay, once we have that, there's a big formula, a couple big formulas. We have that the probability of A and B, 22% and 40%. So your question is, so right here, this 22% is the same as 0.22. I'm not sure if that answers your question. And the 40% is the same as 0.4. Is that what your question was? No, 22% of 40%? No, we don't want that. I just wrote down what's given. That's all we're doing right now. Yeah. So we'll get to this thing, but we need a formula. So probability of A and B is the probability of A times the probability of B given A. We already saw that formula. That happened, half an hour ago or so. Okay. By the way, A and B and A are the same thing. So it turns out if you're looking at A and B, that's the same as B and A. So you can switch the A and B. So probability of A and B is also probability of B times the probability of A given B. I just switched them. I can take this formula here and I can divide left and right by P of B. And when I do that, I get the probability of A given B equals the probability of A and B divided by the probability of B. That's a very, very important formula. Any questions on that? Okay, so now what I can do is I can say I want the probability of N given A. So that means that with this formula, instead of A as the first letter, I have N as the first letter. instead of B as a second letter, I have A as a second letter. Okay, so everywhere I see an A, I'm going to write an N. Everywhere I see a B, I'm going to write an A. So then I could say probability of N given A is the probability of A and N divided by the probability of A. Because notice that here A is a second letter, are on the other side of the given sign, the right side. And the thing on the right side goes in the denominator. You could write N and A, those are the same. I just wrote it alphabetically for the and. And doesn't matter. Any questions on that? Okay, but we also need the probability of A and N. So we need all kinds of things. That's the thing. Well, we know that the probability of A and N is going to be the probability of A times the probability of, and now again, we got to look at the letters, A given N. Any questions on that so far? Probability of A is 0.2. Let's do it in symbols, in fractions. So probability of A and N. Oh, where was I? I don't want that fraction, so I got it backwards. There is what I wanted. Probability of A is 0.2. The probability of A given N is 0.22. Any questions on that? So now we can put that together in our formula. Probability of A and N is 0.2 times 0.22. Probability of A, that was, I have this backwards, just a minute. And, I want an N here. I knew I missed something. That should be an N. And probability of N was 0.4. Sorry about my mistake, but it's fixed. That should be 0.40 times 0.22 divided by probability of A, which is 0.2. That's better. Okay. Now that is equal to, and if you work this out, you get 0.44. You don't have to do it in your head. You can also use a calculator. 0.4 times 0.22 divided by 0.2, and you get 0.44. Okay. I don't expect any of you to do what I did, which is just stick it in your head. Use a calculator. Any questions at all on this question and this answer? Okay. Watching me was a little hard, but do you agree that doing this yourself is kind of like being in a kickboxing ring and having to be there? It's this is a hard problem, but I wanted to give you one example of a tough one that happens. These kind of problems happen. Any questions on that? Okay, so now let's do this one. Hopefully you know what these guys are. Let's see, I just saw P equals PP. P equals PP. I don't quite see P equals PP. There are lots of probabilities in there. Oh, you didn't see what I was doing? Okay, well, here's the screen. Hopefully you see it now. Should be there. You don't see it? You see it now? Right here. Hopefully you see it. I don't see you answering, so I'm assuming you see it. Okay, let's suppose I'm going to take dice and I'm going to roll them, okay? And I'm not going to cheat. I just rolled two-sided dice, two six-sided dice, okay? Find the probability the sum of the dice is a 5. I see P of winning equals P of 5, correct? Finds P of power number. That might have been way down there. Double check. Yeah, it looks like the screen's working. You're seeing that one. Is everyone else seeing that? It might be some kind of time-lapse thing. I'm looking at it. Okay. Not sure. But hopefully it's gonna work in the recording because I'm looking at it, right? Okay, so if I roll the dice, what's the probability the sum is a 5? So what I'm gonna do, and you're used to this, I'm gonna make a fraction. I'm gonna start down here. How many different die rolls are there? Not how many different sums are there, but how many different ways are there to roll 2 dice? How many different outcomes could you get? Here's a thought. You can get a 1 and a 1. You can get a 1 and a 2. You can get a 1 and a 3. I'm not going to go through all of them. Oops, missed. 3. There we go. Okay. Yeah. So there's 6 different first die roll 1s that could happen. There's 6 first die roll 2s. So there's 6 different of these, 6 different of these. So there are 36 different die rolls. Any questions on that? Different pairs. How many give you a sum of a 5? So we want to count them. So here's one of them. Hopefully you can see, I've got it in my camera, that gives a sum of a 5, a 1 and a 4. Okay, so a 1 and a 4, I'm going to use my fingers. You can get a 2 and a what? You can get a 2 and a 3. You can get a 3 and a 2, right? You can get a 4 and a 1. And that's it. If you get a 5, you lost it. You can't. The second one's going to give you a 5. There are 4 different die rolls that give you the sum of a 5. So 4 over 36. Any questions on that? All right. What about the sum as a 7? Once you got the 5, the 7 shouldn't be too bad. The bottom is still going to be 36. Oops. How many sums of 7s are there? There's 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. There's 6 different sum 7 die rolls. Any questions on that? Okay. I think I'm going to skip this one and do this guy. Okay, now we're going to say, let's suppose that a survey was done asking Lake Tahoe Community College transfer students where they plan on transferring to, and what living situation they will be when they transfer. Okay, and my guess is a lot of you are going to go to a university when you're done with this. Maybe not all, but that's a typical thing. And here's a survey, and I will tell you I made the survey up, but you can imagine doing it. And the choices for our LTCC students are Cal State University, CSU, a UC, okay, UC, University of California class. You can go to University of Nevada, Reno. That's our closest university. Or you can go to some other university. You could live in an apartment. You could live with your parents. Or you can live in some other situation. Okay? Dorm room, homeless, I don't know. Okay? And just to note, this is called a contingency table. And to give you an idea, this number 8, for example, that means of all the students who were surveyed, 8 of them are going to transfer to UC campus and live with their parents. Do you see how to read the table? Okay, so a question I have is find the probability that a randomly selected student will go to a UC campus or live in an apartment. Okay, and by the way, just to save time, there are 246 students. If you add up all these numbers, you get 246. So here's the next important formula, and this is the OR formula. And that's the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Any questions on that? And the word or means they could go to UC, they could live in an apartment, they could do both. That's still part of or. Okay? All right, so now I'm going to change these letters A and B to UC and A. A for apartment, UC for the UC campuses. And we can say the probability of UC or A is the probability of UC plus the probability of A minus the probability of UC and A. Any questions on that? And then we just do it. Probability of going to a UC campus. Well, how many are going to UC campus? Well, there's 33 here, 8 here, and 19 here. 33 plus 8 is 41. 41 plus 19 is 60. You're always allowed to use a calculator, but I'm in a hurry, so I'm doing it in my head. Okay, and then divided by the 246. And then plus. And now the probability of A. Fraction. How many apartment goers are there? There's 43 plus 33, which is 76, plus 19, which is 95, plus 22, which is 117. Over, still 246. Any questions on that so far? Okay, then we have to go minus. How many students are going to a UC and going to be living in an apartment? That's easy, that's a hint. Yeah, that's these 33 students right here. So that numerator will be 33. And the denominator will still be 246. Any questions on that? So now you can just do the math quickly if you want. And that is, let's see, 60 minus 33 is 27. And that's 144 over 246. If I did my math in my head. Oops, 246. Any questions on that? Okay, so that's how you do in a contingency. Okay, now a couple definitions that are really important. Two events are mutually exclusive. Very important words. if it's a formula, probability of A and B is equal to 0. Okay. Are transferring to a CSU and living with parents mutually exclusive? Well, what's the probability of CSU and parents? So I make a fraction. How many are going to CSU and living with their parents? 34. And that's out of 246. And hopefully you know that that's not equal to 0. The only way you're going to get 0 in a fraction if the numerator is a 0. So then, thus, they are mutually exclusive. I'll write ME for mutually exclusive. Okay, what about transferring to a CSU and transferring to UC? Are those mutually exclusive? Yeah, the probability of transferring to UC and CSU, well, there are 0 students transferring to both. You're not allowed to. So that's 0 over 246, and that is 0. So they're mutually exclusive. Okay. Oh, these, is that right? Is? I'm not. Sorry about that. Are not. Yeah, these are not mutually exclusive. Sorry about that. Okay, here comes the next big formula, and this is a harder one. That is 2 events A and B are independent if any of the 3 formulas are true. Probability of A and B equals the probability of A times the probability of B. Probability of A given B equals the probability of A. Probability of B given A equals the probability of B. So if you look at the second one, for example, this says that if you know B happened, that doesn't change the probability of A at all. It's the same. And similarly, if you know A happened, that doesn't change the probability of B. But this multiplication principle without a given becomes true if either of these others are true. And if any of these are true, they're all true, and we call it independent. If any of those are false, they're all false, we call them dependent. All right, so now we don't have much time, so I actually just did it. Are living in an apartment and transferring to UNR independent? So what I can do is I could say probability of apartment given UNR. So now, probability of apartment given UNR, probability of apartment and UNR is 19. Probability of apartment given UNR, that means that we're just in this column, 19 plus 7 is 26, plus 15 is 41. Okay, so that will be 19 over 41, or about 0.463. Probability of living in an apartment, well, that's going to be, we already actually found that out, probability of apartment. We had that somewhere else, didn't we? There we go. That was this guy, which was 117 over 246. And if you work that out, you get 0.475, etc. Okay, 0.463 is not equal to 0.475. So since they're not equal to, we could say apartment and UNR are dependent. Okay, kind of the idea of dependent is if you're told one is true, that changes the probability that the other is true. Any questions at all on that example and independence? Okay, I don't have that much time, so I'm going to do the one example, but there's lots and lots of other ones you'll see on the homework, etc. And the secret word, which doesn't mean we're done, the secret word is and. Very simple word to spell. If you don't know how to spell and, that's not good. So and is a secret word because and was one of the big things in probability. Any questions at all on probability? Okay, what I want to do now is I want to talk about the project. So if we go to the syllabus, by the way, I've said it now, so automatically if you go to the class, it goes to the modules, but sometimes you want to go to the syllabus. And you scroll down. Then we have two projects for the class. Project 1, you're going to collect quantitative data, and you're going to use a computer to display each of the charts discussed in the class. Okay? So if I click on Project 1, and by the way, I mentioned this in the orientation, you must work with at least one other person, but strongly recommend there's 3 of you in a group. And again, use the project discussion forum. Project 1 discussion forum to find partners is kind of the best way of doing it. Okay, and hopefully you all have partners. Otherwise, go find partners. You have to find partners. If you say, is it okay if I don't find a partner? Then I'm going to say, remember, there's a huge penalty. You pretty much almost can't get a passing grade for the project, and I'm going to be strict on that. You need to have partners. And if there's 3 of you, there's a much smaller chance that 2 drop out. So make sure you have partners. Okay, so now I'm going to go and talk about the details of Project 1. Think of a quantitative investigation that someone might contract out to have done. So who remembers what the word quantitative means? We talked about that last week. Yeah, that means it's going to be a survey question at which the answer to the survey question will be a number for each person, a different number, but a number. Okay. So one thing I suggest you do is ask your partner the survey question. If your partner doesn't answer with a number, this project will not work. Got it? I will let you know, and this is going to come a little later, it's best if you can make sure that you have 2-digit numbers at least that are answered. And that has to do with stem and leaf, which we'll talk about that in a little bit. Okay, you need to think about someone who might contract out to have it done. Now you don't actually have to get someone to pay you. Okay, you're allowed to, but that's almost, I have had actually, I think twice in my many years of doing this where 2 different groups that 2 different people got paid because it was for their job. But you don't have to do it for your job. But you have to at least imagine someone that might be interested enough that they might pay, even though it's just an imagination. And it might be someone that you can never get in touch with, like, say, President Biden. Good luck. I mean, you can try calling Biden, but I don't think I could call him. He wouldn't answer my phone. But you can imagine President Biden paying for this kind of thing. Okay? Or whatever, someone who might be interested in whatever you're asking, whatever you're researching. Okay? Then you're going to perform the investigation and produce a report as though you were handing the report to the person paying for your services. You can assume, even if it's not true, that the person understands statistics. So, use statistical vocabulary in your project. That is important. Okay, but don't write it for me, write it for your, the audience is going to be that person. Yeah, you're actually going to do a real survey. I'm going to get you, I'm going to explain in a minute. No fictitious numbers allowed. Okay. And we'll get that in the next paragraph. Okay. So in your paper, you have to talk about who has hired you in theory and why. Okay. And that's important. And also throughout your entire paper, I'm going to say this more than once, you have to make recommendations throughout the paper to your client, the person who hired you. Okay. Now, you have to use a description of the sampling technique that was made and how the technique was applied. Okay. So the question is, do you have to do a real survey? The answer is absolutely yes. You have to do a real survey. Even during COVID, I made everyone do a real survey. But what were they allowed to do? Or what did everyone do for their real survey? How'd they do it? Call? Almost nobody called actually, online. Yeah, kind of phones are like old fashioned. Almost everyone did an online survey. You're allowed to do an online survey. There's some issues with online surveys, just to let you know. But you're also allowed to do face-to-face. Just let you know that. Okay. You must either use simple random sampling, stratified sampling, or cluster sampling. Any guess on why I have a link to stratified sampling and a link to cluster sampling, but I don't have a link to simple random sampling? Any guess? Might be a hard one to guess, but you might be able to guess. You guess? Not seeing you guess. Okay. Yeah, simple random sampling is almost always impossible. So good luck. You have to identify who your population is. For example, if your population was, say, Californians, you cannot do simple random sampling. Because even if you can somehow get a random sample of 31 Californians, you're not going to get them all to answer your question. And you can't get a random sample. So if you think you could do simple random sampling, think again. Take stratified sampling, that's very doable. Pick a strata and do it. Or cluster sampling, that's very doable also. Okay. In your paper, you're going to discuss any bias that might have occurred due to your sampling technique. If you think there was no bias, think again. There's always some bias. It doesn't mean it's completely unreliable. It means that there's some bias. Okay? And just about every sample has bias. I do not take off points if there's a lot of bias. I take off points if you don't identify the bias. Does that make sense? So note that bias involves a misrepresentation of the population. So the sample data will not represent the population data. So in your paper, you should talk about the bias and saying, well, because of this bias, we suspect that the sample mean is lower than the population mean because of this bias. Do you see that? It's just a suspect. You don't know for sure, but you can suspect because of that bias. It looks like those kind of people will answer a lower number or something like that. Okay, if there's no reason for them to answer a lower number, then it's not bias. So for example, if I did a survey asking college students, how many units are you taking? But I only asked people with type A blood. Is that bias? Okay, you say yes. The answer is no. People with type A blood don't take a different number of units than people with type B blood or type O blood. Does that make sense? There's no bias in that. Okay, on the other hand, what if you only asked 18-year-olds? Is that bias? What do you think? Yeah, that's bias because 18-year-olds tend to take fewer units than older people. It turns out because older people often have full-time jobs, for example, or families, children they're taking care of. Okay, so that you would think that there would be a bias, and it would bias it to be on the high side of number of units. Do you see that? So that's what you should be talking about in the bias. Okay, and by the way, I'm not saying you should only ask 18-year-olds. I'm just giving you an example. Okay. So talk about the bias. Any findings of potential bias should provide a convincing argument of why you think the sample is more likely to have a higher or lower mean. The variable must be quantitative. I said that already. The sample size must be greater than 30. Okay. I want to let you know that we have not talked about why 30 is important. 31 is fine. 30 is not fine. That's going to come up in a few chapters. That'll be in chapter 7. You'll understand why 30 is important. We're not there yet, but I want you to all know that over 30 is important. Got it? Okay, if you have anything 30 or less, that's bad. Okay, and those are the number of people that answered your survey. Okay, Be careful not to use the word random without fully explaining what you mean. Most people say, oh, randomly ask people. Good luck. You can't randomly ask people. Okay. Any questions on the sampling? Okay, once you have your sample and once you have your data, what do you think you're going to do once you have your data? Any guess? What's the next step? You as in, the three of you, possibly two, but hopefully three. As you're guessing, I'm going to do it, but maybe you'll guess before I do it. I'm going to my Google Drive. And I'm going to Statistics by Larry Green. Okay. Remember I showed you this in the orientation, I think? I think it was orientation. If not, you've seen it now. The first thing you have to do is you're going to have to go to File, make a copy. You only do this once in the entire course, by the way. And only one of you in your entire group have to do it. Okay. It sounds like it's extremely difficult. It's actually not that difficult. Sample size of 31 does not take long. Okay, I promise. Okay. Once you do that, what you're going to do is you're going to highlight the column A numbers. Why is it not letting me? Let's try this. There we go. Hit the backspace. And then you're going to type in your data. Let's say you got 55, and you got 67, you got 12, you got 99, you got 13, you got 52, etc. Okay? And that will give you the statistics. I think I've shown you this before. It also shows you the histogram. Remember, you can get the box plot and stem and leaf, which you'll also have to do. You go to box plot. There's a box plot. You go to stem and leaf. There's a stem and leaf. And I do want to let you know what you do need to do is you need to highlight these two columns. You need to copy and paste them and put them into your project. Got it? That's not hard. You just got to remember to do it. And similarly, you got to copy and paste, okay, or make screenshots of the histogram, the stem and leaf, and the box and whiskers plot. So screenshots should be in there. Okay. Also notice there's a z-score question. You got to put that in. It says change this. Do not use whatever I used last. It's going to be a different number, whatever you think is important, okay, for outliers, etc. I see wait. I'm not sure what I'm waiting for. But that's something you have to do for this project. You want us to include this particular info in your project? Yeah, I'm going to talk about all the info you have to include in a moment, but I need to leave the screenshot. I need to leave the screen. Whoops. I want to go to that one. There it is. Okay, so you must include a histogram. You must include a stem and leaf, and that's why you want to have at least 2 digits. If you don't, then you can't really do a stem and leaf. You have to have a box and whiskers plot. You can include a pie or a line plot or something else if they're relevant. If they're not relevant, you don't have to. But you have to include at least these 3 plots. Okay. You have to use a spreadsheet program and not the calculator. Okay. Also, it's not a comparison study. You're not comparing this group with another group. You're just looking at one group. Okay, so you should just have a single column of data. Okay, any questions about that there? Okay, you're going to interpret each of the charts in the context of your study. Discuss what each chart says and what does not say. Compare and contrast the charts and state what audience each chart might be best for. Talk about the pros and cons of what each chart tells you that maybe the others don't tell you. That should all be in the project. This is a lot of work. That's why I'm giving you a bunch of weeks for it, or a few weeks at least. Okay, you're also going to list the summary statistics, and you're going to interpret each. So the main ones are the mean. Maybe I should get rid of variance. Variance is not really important. But the mean, the standard deviation, you're also going to be looking at a z-score. You're going to be looking at Q1, Q3, the interquartile range. Okay, there's all the stuff that we've talked about in our class. Okay, the standard deviation is the biggie. Okay, that's the new one for our project. And you have to have at least a full paragraph devoted to the standard deviation. I will never give an A if you don't have a full paragraph. It doesn't mean you always get an A, but you can't get an A without a full paragraph, just on the standard deviation. And that'll be things like the empirical rule in Chebyshev's theorem. That's all part of the standard deviation, the z-score. Okay, so remember, you look at the empirical rule or Chebyshev's, depending on the shape of the histogram. The histogram looks pretty normal, somewhat normal at least. You can use the empirical rule, otherwise you can't, and you have to resort to Chebyshev's theorem. Okay, talk about the z-score. You should be looking at important values. Those are, one is possible outliers to see if they're outliers or not. Others might be, let's say you wanted to find out how long people sleep. Okay, then 8 might be an important number because that's the recommended number of sleep hours. Do you see? Okay, you should give a synopsis of the importance of your findings. You should include recommendations, okay, for everything, mean, standard deviation, the IQR, all the charts. Each one, you should be talking about recommendations throughout the paper, not at the end, okay? I'll let you read this. I can't read everything. We only have so much time. It's already 37 after. Okay, a couple things. This is really important. Who are you absolutely not allowed to survey? Yeah, you're not allowed to survey any minors who are not fellow college students. Okay, if there's someone who's 17 that's taking this class, you're allowed to ask them. You are not allowed to go to a high school and ask students, or go to an elementary school, or or ask little kids who are running around in a park. Okay, that is absolutely not allowed. It is against the law. So don't even think about it. Because if I told you you could, I could go to jail for it. Okay, now this is recorded, so I know I can't, but you don't want to go to jail either. You are not allowed to ask minors. Got it? Okay, so don't ask minors. That's really important. Okay, I want to mention a few things. I'll let you read through some of this other stuff, but I want to mention that the project is due by February 11th. That's almost a month from now. It seems like a long time, doesn't it? Okay, seems like a long time. Time moves fast. So you should really, what I recommend is establish a timeline with your partners. So the first thing, and hopefully you already did it, what was the first task of the project? First task, which most of you already did. Yeah, getting partners. So there should be 3 of you, hopefully, and you've got partners. That was number 1. Okay, task number 2, and I recommend doing it this week. That is meeting with your partners. That doesn't have to be it doesn't have to be face to face. It could just be, you can email each other, you can chat on some Zoom thing or whatever. Just however you like to meet with people. Online is great because we're an online class. But meet with them, talk about your idea. Come up with something you can agree on for an idea for your project. Okay? And in the ideas, you should be thinking about what your survey question is, who your population is, what your sampling technique is going to be, and how you're going to accomplish that sampling technique. Okay, and who your client is. Got it? Then, right after doing that, once you have decided, with your fingers crossed, I want you to post in the Project One discussion board your project proposal that has the 3 things I just told you. Okay, the survey question, the 4 things, sorry. Survey question, the population, the client, and your sampling technique. And then I will look at that post and I will let you know if it's going to work or not. Usually I'll have things to say, like, hopefully not, oh, this won't work at all because this can't work. Your survey question is a yes/no question, for example. That's never okay. More often, I'm going to say, well, it's pretty good, but you may want to change the wording a little bit. like this, because then you'll get better numbers because you don't have two-digit numbers or something. Or maybe I'll say, well, your sampling technique's not perfect. You might want to think about this because whatever, breaking the law or something like that, or you're not going to find enough people. Does that make sense? Or you're not really using clusters, you're not planning your cluster sampling correctly. There was a whole lot of chat things. Let me see what they were. Can you repeat them one more time? I think them is the things. Yeah, it's a survey question, your population, sampling technique, and who your client is. It could be Joe Biden. It could be Jeff DeFranco. Do you know who he is? That's the president of our college, president of Lake Tahoe Community College. So he could be a client if he'd be, because he'd be interested in students. It could be the school board. Okay. Which, by the way, I was on the school board once, the college board, though, which I wasn't on. It could be, there's lots of different people. It could be the head of some company that might be interested for some reason, Does that make sense? There's lots of different, people you can choose. Just choose someone that would be interested. Any questions on that? Okay. So again, then the next step, once I say it's okay, is to collect your data. And that shouldn't take very long. We're talking about surveying 31 people. There's 3 of you, so basically 11 people each. How long does it take to do 11 people? Okay. If you're going to go into a classroom, get the instructor's permission before you go in. Got it? And I mean a college classroom. So if your population was Lake Tahoe Community College students and you wanted to walk into a biology class, make sure you ask the biology instructor. They'll almost always say, sure, no problem. But they might say, but do it at the beginning of class or something like that. But ask them first. Got it? If you're going to do it at a business, make sure you ask the manager first so that they're okay with it. You don't want to go to jail or get in trouble, especially if you work there. Does that make sense? So if there's an important person to ask permission first. Then conduct your sample, get your over 30, so at least 31. And then once you get your data, what do you do next? What's the next step after collecting your data? You now have your data, you've shared it with your partners. Yeah, you put it in a spreadsheet. Okay, and then once you put it in a spreadsheet, the next step is to write your paper. And I recommend, cutting it into pieces so each person has a piece of it, and then share it with each other. So read all, you read it all, but you write your pieces. Does that make sense? And then you help, refine and modify to make better the pieces. Then the next step, once you have your project written, what's your next step? Any thoughts? Histogram, no, that was all done in the spreadsheet. That happened a long time ago. Yeah, you send me an email with your project. You send me an email with your project. I will read it and I will give you many comments for improvement. And I'll tell you, that really helps your grade go up. And I want you to do well. But if you don't send it to me, I can't do much. Does that make sense? And again, the last possible deadline is going to be the Thursday before it's due. February 11th is a Sunday. So if you subtract 3, that would be February 8th, 8 in the morning. But don't wait till 8 in the morning. I would do it like actually a couple days before that, like on a Tuesday, like February 6th, which still is a long time from now. And then I'll look at it and then I'll give you lots of suggestions. And then the next step is to address all the suggestions. And then your last step, which I recommend doing on February 10th, is submitting it. Should never wait till the last minute to do something important, because that's when things can go wrong. Does that make sense? And that's a timeline. So I would work on that timeline and make sure you get everything done in time. Don't wait until the beginning of February to start working on this project. You should be working on it like tomorrow. to meet with each other, maybe in a couple days, but don't wait like weeks. Then you have plenty of time. All right, it's 2:46. This is about as long as we go for the webinars, because what I don't want to do is, waste all your time. But there was a lot to talk about because of the project. This might be the longest one there is. So what date should you send the project info for the feedback? So you mean at project info like your project idea? Is that what you mean by info? So project idea, I recommend next week. That'll give you lots of time to start working on it. The project draft, which is your formal long, probably 12-page paper, including all the charts and stuff. That one I recommend like on the 5th or 6th of February. Because that takes a long time. Does that answer your question? Yeah. Yeah, don't wait till the very last allowed minute, which would be, 7:59 in the morning on February 8th. I'd do it because then if there's a few that do it at the last minute, then it takes me a while to read them all and do the drafts. I can't read 12 pages in 5 minutes, just let you know that. So if there's like 4 of them, then it's going to take many hours and it might take a couple days before I get back to you. Do you see? Just because of how many hours it takes. Okay. So I think I am going to stop the recording.